First thing we need to recall, slope-intercept form is y equals mx plus b, right? We could also say f of x equals mx plus b. You could see it either way. They're both slope-intercept form. Remembering that m, whatever that coefficient of x is, m is the slope of our line, and b is the y-intercept. So wherever the line crosses the y-axis, that will be our b. So when we look at the graph of a line, if we can find its slope, which we can by finding the rise over the run or using slope formula to find the slope, and if we can find the y-intercept, if we can see that on the graph, then we can write an equation of that line, okay? Let's do an example. Example 1. All right, so this tells us write an equation of the line. So for this one, letter A, we're going to write an equation, and they tell us that the slope equals -3, and the y-intercept equals 1/2. And we have to put this into the equation of a linear function in slope-intercept form. Well, this is super easy because we have the slope and we have the y-intercept. So we start with knowing this, that y equals mx plus b. Do we know m? Yes. Do we know b? Yes. All we do is plug in. So y equals, instead of m, I'll plug in what I know is my slope, -3. Don't forget x, right? It's -3x plus 1/2, because we're told that our y-intercept is 1/2. That is b in this equation. So that's it. Don't forget to put the x. So this is one of the most common reasons that you'll get stuff wrong, is because you forget the x. You plug in the m, you plug in the b, and then you check it and it's wrong. And then you're like, I don't know what I did. Always check that you remembered to put that x in there, okay? Letter B. This one says when the slope equals 0 and the y-intercept equals -2. Couple ways you can think about this. What does a line look like when its slope is 0? Joey? Just a horizontal line, right? So it does not have a slope. So this is going to be the equation of a horizontal line. Now, if you're feeling super comfortable with that at this point, you can just write the equation of a horizontal line, y equals -2, or plug it into slope-intercept and simplify. Y equals mx plus b. Do we know m? Yeah, it's 0. Do we know b? Yes, it's -2. So we can just plug in here. Y equals, m is 0, so 0x minus 2. And then we always want to finish up in simplest form. 0x is just 0. And 0 minus 2 is -2. So their final equation is just that y equals -2. Nathan?
So if you put just x there, would it be wrong?
Yes, because you don't have an x.
Okay.
You have 0 x's,
Okay.
right? And if you just put x, that would mean you have 1 x.
Okay.
So it has to fall out completely. Good question. Does that make sense? Okay, let's look at another example. So this one gives us, example 2, gives us a graph. So letter A looks like this. All right, and they have 2 points labeled on this graph, one at 0, -3, and one at 4, 3. Okay, they give us this, and then they say write an equation. Write an equation from the graph. In order to write an equation from this graph, we need to know the slope of the line, and we need to know the y-intercept. Can we find both of those from the graph? Yes. What can we see most easily right off the bat? The y-intercept, right? We can look at the graph and we can very quickly see the y-intercept. What's my y-intercept, Emma? -3. Okay, my slope we can find one of 2 ways. What are the 2 ways that I can find slope? Charlie, give me one. Rise over run. So we can actually count up our rise and over our run. What's the other way we can find slope, Lainey?
y2 minus y1 over x2.
Good. We can use slope formula. We could label our points, x1, y1, x2, y2, and plug it into slope formula. Either way will work, so it just depends what you want to do. I'm just going to do rise over run for this one. I'm going to count. We'll do the other one with slope formula. So we'll do one of each. So this one, if I was going to count, I go up 1, 2, 3, 4, 5, 6. My rise is 6. And then my run is 1, 2, 3, 4. So my slope then is rise 6 over run 4. And I always must simplify. 6 over 4 simplifies to 3 over 2. And then just leave it as an improper fraction. Don't make it a mixed number. Charlie? That's fine. You could do that as well. Yep. So what he's saying is he started here and went up 3 over 2, and that was simplified. But that should be true. You could pick literally any point on the line and count rise over run. You should always get the same slope. Okay? All right. Once we have the slope and the y-intercept, we just plug in to our slope-intercept form. mx plus b, y equals mx plus b. And now that we know m and b, we just plug them in. Y equals, our m is 3 over 2. So 3 halves x minus 3. That's the equation of that line. Good? Okay, let's look at letter B. This is another one where they give us a graph. I'm going to use slope formula for this one rather than counting rise over run, just so that we see how to do it both ways. Here's our graph. All right, it gives us 1 point at 0, 2. And 1 point at 4, negative 1. The directions are the same. Write the equation of this line. In order to write this equation, we need to find the slope of the line and the y-intercept. What's really easy for us to see on this graph? Right off the bat, without doing any math, what can we see? What's the y-intercept? Good. What is it? 2. It hits the y-axis at positive 2. Now the slope, you have to do a little bit of calculation, whether that's counting rise over run, or using slope formula, you have to do a little bit of work to find the slope, okay, when it's not just given. I'm going to use slope formula for this one. So I'm going to label my points, x1, y1, x2, y2. And then I'll use slope formula, y2 minus y1 over x2 minus x1. And then I just plug in the points that I've labeled. y2 is negative 1 minus y1, which is 2, over x2, which is 4, minus x1, which is 0. Then when I simplify, I get negative 3 over 4. That's my slope. Can't simplify that any further. It's a fraction in simplest form. So my slope is negative 3 over 4. That makes sense as well because I look at the shape of this line. This line would have a negative slope. It's falling from left to right. Okay. Then my last step is to plug in what I know to slope formula. Not slope formula, point slope. No, slope-intercept form. Okay. Y equals, my m is negative 3/4, so negative 3/4 x plus y-intercept, which is 2. So negative 3/4 x plus 2. Okay? So either way, however you want to find the slope, either way, as long as you do the math correctly, is fine. You can count, rise over run, or you can do slope formula. Okay. Let's look at example 3. They might give you some like this. They'll say, write an equation of the line that passes through the given points. Write an equation of the line that passes through the given points. Okay, we don't have a graph here. You're welcome to always draw a graph, but we can do this without drawing a graph as well. What can you see here right away? Nathan?
The y-intercept.
Good. What's the y-intercept?
-1.
Yes. Remember, the y-intercept always occurs when x equals 0. So we can see from these 2 points that this is our y-intercept. In this lesson, they'll always give you one of the points as the y-intercept. Okay? So we can see our y-intercept is at negative 1. What's the other thing that we have to find? Slope. How are we going to find slope from this set? Maeve? Yes, we're going to use slope formula. So I'm going to label these x1, y1, and x2, y2. Oops, x2, y2. And then I'll plug it in. y2 minus y1 over x2 minus x1. And we'll find the slope. All right, my y2 is negative 1 minus y1, which is 5, over x2, 0, minus x1, minus a negative 3. When I simplify, I get negative 1 minus 5 is negative 6. 0 minus negative 3 is really 0 plus 3. Positive 3. When I simplify this further, negative 6 divided by 3 is, Emma? Negative 2. My slope, then, is negative 2. Once I've found these, I can just plug them in to slope-intercept form. Y equals mx plus b to get the equation of that line. Y equals, my slope is negative 2, so negative 2x minus 1. Okay? Let's look at this one. That was letter A, if we want to label it. And this is letter B. Same thing, it's going to give you 2 points. We need to find the equation of the line passing through these 2 points. See if you can do this one on your own. I'm going to give you a minute to try to work this one out on your own in your notes. Yeah. All right, when you're done, did you get this? Very good. So this is a horizontal line. You could kind of see that something was a little weird from the beginning, right? So that was our sort of hint that it was going to be a horizontal line. But we should also be able to find that by using slope formula. Remember, it's always okay to have a 0 in our numerator. If we have 0 eighths, we have nothing. Simplifies to 0. Okay? All right, the last way that they might present this to you is giving it to you in function form. So we just sort of have to remember how to work in function form. Example 4. It says write a linear function with the values f of 0 equals 10 and f of 6 equals 34. Remember, function form, this value inside your f of whatever, this is an x, and whatever it equals is a y. These are really ordered pairs, right? You could rewrite these as ordered pairs. So this point is at 0, 10. What would this point be? Maybe 634. This is always an x, and this is always a y, because this is an input and an output. From here, we just do the same thing that we did last time. The trick is getting from function form to 2 points. Okay? This is where you're going to be like, I don't know how to do it. Remember that function form, this is an x, and this is a y. These are 2 points of an ordered pair. And if we can get them into ordered pairs, we just do the exact same thing that we just were doing. We can find the y-intercept, and we can find the slope. What's the y-intercept of this line? 10. And the slope we can find using slope formula, just plugging in. So y2 is 34 minus 10 over 6 minus 0. So we get 24 over 6, which simplifies to just 4 for our slope. Then the last step, put it all together, write the equation. In this one, since it gave it to us as function form, we're going to write our equation as f of x equals mx plus b. So we'd say f of x equals our m for x plus our y-intercept, which is 10.
Did you get counted wrong, like on you say like y instead of f of x?
No, but you might online because it's very persnickety. Okay, the last thing I just want to do the little word problem practice. This is example 5 because it will be similar to the one you see on your homework. So example 5, this is our word problem. It says, so, okay, let's just recall. When we're looking at word problems, slope is typically a rate. Slope is typically a rate, so miles per hour, meters per second, gallons per day, something per something, dollars per t-shirt. Slope is typically a rate, right? And the y-intercept, this is also important, the y-intercept in a word problem is typically a starting point. So whether it's how much money you started with or how many feet high the fall is, like if it's falling off a cliff and the cliff is 500 feet high, that's the starting point. When you're looking at a word problem and you're trying to write an equation, look for the slope, which is typically a rate, and look for the starting point. That's usually your y-intercept, okay? All right, so let's listen to this. It says, excluding height, this is like the longest word problem ever. U.S. power plants use renewable energy sources to generate 105 million megawatt hours of electricity in 2007. 105, I don't even know the abbreviation for megawatt hours.
It's MWH.
Thank you. Megawatt hours. That's not even a good W. Whatever. Megawatt hours in 2007. By 2012, the amount of electricity generated had increased to 219 megawatt hours in 2012. Write a linear model, that's a linear equation, that represents the number of megawatt hours generated as a function of years since 2007. Use the model to predict the number of megawatt hours that will be generated in 2017. So, step 1 is to write the linear function, or linear model, they might call it. Same idea, it's the same thing. Write the linear function. Okay, and we're only going from 2007 on. We're only going from 2007 on. So what is our starting point in terms of values? Let's not get this so crooked. What's our starting point? Joey, where do we start? 2007. What was the initial amount of megawatt hours that we're starting with? Good. God, I can't get this straight. Sorry, this is really annoying, guys. Okay. This is our initial value. If we're starting in 2007, we're not looking at years prior to that. So on our graph, if we were going to graph this, time is almost always our x-axis, and our y-axis, in this case, megawatt hours. So our starting point, time is starting in 2007, and we start with 105 megawatt hours, right? You know this because they told you it in the problem. They say, what does it say? Write a model that represents the number of megawatt hours generated since 2007. So that's where we're starting, 2007. Do we know another point on this graph? Right, we know this point as well. We also know that 2007, 8, 9, 10, 11, 12. In 2012, how many megawatt hours are we generating? 219, so it's gone up. Now, notice my x value here is not going to be 2012. What's it actually going to be? This is 0, right? We started here. So it's 5 more, right? 5 years later. This is basically years since 2007, right? So this is really at 5 to 19. 0, 1, 2, 3, 4, 5. So this is really years since 2007, since that's where they told us we were starting. From here, can we write a linear model that shows us how this data is related to one another? Yeah, right? We know the intercept. What's the intercept at? 105. And we can figure out the slope either by slope formula, or by counting. Which do you guys want to do? Counting? Okay. From here we went up. We go up to 1, 2, 3, 4, 5. My graph is not totally. My rise is 5, right? We go up 5. And then from, wait, no, that's wrong. We go up, no. No, we don't go up 5. We go up from 105 to 219. This is why counting is hard on these.
You go up 114.
Yeah. I'm going to do, because my graph is not to scale, and typically it's not to scale when you have numbers this big, right? It's easy to count rise over run when you're going by ones, but when you're not, it's usually easier to use slope formula. Because then you just plug in and do the math, and you don't mess yourself up by trying to count like by 10s or 5s or 15s or whatever the heck my denominations are. So if we plug in y2 minus y1, x2 minus x1, we get 219 minus 105 over 5 minus 0. Which gives us, what is it, 114? 114 over 5. You can leave it as that improper fraction, or we could simplify it to an actual unit rate, because it needs to be a rate of something per something, right? This is going to be, for us, megawatt hours per year. If we simplify that, it becomes 22.8. You don't have to, but in a word problem, it makes it easier to describe. Like having it over 1 makes it a unit rate. And it's, how many megawatt hours per year do we use? 22.8. That makes more sense than saying we use 114 over 5 megawatt, right? So for the word problem, it a lot of times does make sense to put as a decimal. All right, so if we're going to write the equation of this line, what is it? Very good. Y equals 22.8x plus 105. This is the linear equation that models what's happening with that data. Part 2 asks us, use the model to predict the number of megawatt hours that would be generated in 2017. Right, so in 2017, how many years later is that than 2007? Now, how many years later is 2017 from 2007? 10. So where would we plug in 10 here? For x, because remember, x is our years since 2007.
So 228.
So we would say, yep. $228 times 10, because x represents years since 2007. We're asked about 2017. So that's 10 years later, plus 105. So then we just do 228 plus 105. How many megawatt hours would be generated if it continues with this trend? Good, 333. Yep. Megawatt hours we would expect to see in 2017.
It's M capital W then H.
I knew I had that wrong the first time I wrote it. Megawatt hours.
Yeah.
Oh, you don't be sorry. You knew it. Very good.